Good morning, everyone. I am K. Narsimurthy, working as an assistant professor in the Government First Aid Women's College, Tumkur. I am going to present a video for the second semester student of Tumkur University, and the topic is vector. See, in Tumkur University, second semester physics total syllabus has been divided into 4 equal parts. So each part we are calling it as unit. Okay, so we have 4 units for the second semester students. So equal weightage has been given to all the 4 units. So I'm going to discuss the first unit today. Again, in the first unit, I am going to discuss the first hour. So each unit has been given 15 hours. So I am going to discuss the first hour in the first unit for second semester students, and the subject is physics. So the topic is vectors. So vectors, you have already learned in the second PUC about these vectors. You know, any physical quantity, you know what is physical quantity is. Physical quantity is one which can be measurable. So I can give you an innumerable example for the measurable quantities. That means the physical quantities. Suppose take a length, mass, acceleration, force, momentum. These are some of the example for the physical quantity. There are many other quantities which are not physical also. I can give you an example for other quantities. Suppose hate. I hate mathematics. Hate is a quantity, of course. It is not a physical quantity. How much you hate mathematics? It is not measurable. I love physics. Now, how much you love physics? So, love is not a measurable quantity, and you cannot consider it as a physical quantity. Now, you understood what is physical quantity is. So, physical quantity in majorly has been divided into two parts. One is vectors, another one is scalars. So, you already know that the scalar quantity is a physical quantity which has only magnitude but not the direction. I can give an example for the scalar quantity as well. So mass is an example for scalar quantity. If you take a 1 kg of tomato, so its mass is 1 kg. Okay, so it has no direction, it has only magnitude. The magnitude is 1 kg, mass is 1 kg. So length. Suppose you take a table and you measure the length of the table, and the length of the table it's come out to be 1.5 meter. So what's the length means? It's 1.5 meter, no direction at all. Okay, so magnitude is 1.5 meter. So that is the scalar quantity, the quantity which has only magnitude but has no direction. So there is another quantity which is called vectors. So this is the focus of the first session. So vectors are the physical quantities which has both magnitude as well as direction. Okay, I can give an example, you will understand better now. So example is the velocity. When you mentioning an velocity, you need to mention with the magnitude and the direction of it. Okay, suppose if bus is moving, you say that bus is moving with a 50 kilometer per second speed and in this direction. That complete explanation will give you the velocity. Okay, similarly acceleration, you mention with the direction and magnitude. Force, you mention both, and the momentum we mention both. So these are some of the quantities which are very good example for the vectors. So vectors are graphically represented by this symbol. We have a symbol here, this OA. One is tail, another one is head. Okay, so this O end is the tail and this A end is the head. We have an arrow mark at the head. This is how we represent graphically a vector. Okay, now we need to understand the different type of vectors. We have a many different type of vectors. We'll go one by one. Though the first vector is unit vector. Unit vector is a vector quantity which has unit magnitude Okay, and the direction of a unit vector is same as that of that given vector. Okay, suppose A is a vector. If you want to mention the unit vector, you call it as I cap. Suppose B is a vector, you have to mention an unit vector for this, that's a j cap. Okay, so unit vector is a unit vector of a given vector is a vector quantity which has unit magnitude. Unit means 1. Okay, it has unit magnitude, and we look at the direction of unit vector. This direction of unit vector is same as the direction of a given vector. Okay, so we have written here p cap. So unit vector is represented by the cap. Okay, so here it is p cap. P cap is equal to p vector divided by magnitude of p. If p by p is 1, so if you take a magnitude of unit vector, it is 1. Okay, right. So null vector. Null vector is a vector whose magnitude is 0. Okay, so for the null vector, the magnitude itself is 0, and you no need to tell the direction of it because magnitude itself is 0. Okay, equal vectors. Suppose if you take two or more vector, when you have to say that these vectors are equal, their magnitude must be equal and they should have same direction. Okay, ಎರಡು ಅಥವಾ ಮೂರು ವೆಕ್ಟರ್ ಒಂದೇ ಡೈರೆಕ್ಷನ್ ಇರಬೇಕು, ಒಂದೇ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಸಹ ಹೊಂದಿರಬೇಕು. Okay, so when that and irrespective of the position in space, they can have different positions in the space, but the condition is magnitude must be same and direction must be same. Okay, one vector ಅಷ್ಟು ದೂರದಲ್ಲಿ ಇರ್ಬೋದು, ಇನ್ನೊಂದು ವೆಕ್ಟರ್ ಇಲ್ಲಿರ್ಬೋದು, ಬಟ್ ಎಲ್ಲೇ ಇರಲಿ ವೆಕ್ಟರ್ಸ್ ಒಂದೇ ಡೈರೆಕ್ಷನ್ ಹೊಂದಿದ್ದು ಒಂದೇ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇದ್ರೆ ಅಂಥ ವೆಕ್ಟರ್ನ ನಾವು ಈಕ್ವಲ್ ವೆಕ್ಟರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಅವು ಎಲ್ಲಾದ್ರೂ ಕೂಡ ಇರ್ಬೋದು, ಇರ್ರೆಸ್ಪೆಕ್ಟಿವ್ ಆಫ್ ಪೊಸಿಷನ್ ಇನ್ ಸ್ಪೇಸ್. ಸ್ಪೇಸ್ ಅಲ್ಲಿ ಇರ್ತಕ್ಕಂಥ ಯಾವುದೇ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ವೆಕ್ಟರ್ಸ್ ಇರ್ಬೋದು, ಬಟ್ ದೇ ಹ್ಯಾವ್ ಟು ಹ್ಯಾವ್ ಎ ಸೇಮ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ and the same direction. Okay, and such vectors are called equal vectors. Okay, parallel vectors. So two vectors are said to be parallel if the angle between them is either 0 or 180 degree. Okay, they cannot call it as equal vectors because the magnitude need not be same here. For parallel vector, the magnitude doesn't matter. The two or more vectors can have any magnitude. The only condition is the angle between the two vectors must be 0 or 180. 0 means they are in the um, same direction, and 180 means they are in the opposite direction. Okay, but the thing is angle must be 0 or 180 between those two vectors, then those two vectors are called as parallel vectors. ಎರಡು ವೆಕ್ಟರ್ಗಳ ಮಧ್ಯೆ ಆಂಗಲ್ 0 ಇರಬೇಕು ಅಥವಾ 180 ಇರಬೇಕು, ಹಾಗಿದ್ರೆ ಮಾತ್ರ ಆ ಎರಡು ವೆಕ್ಟರ್ನ ನಾವು ಪ್ಯಾರಲಲ್ ವೆಕ್ಟರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. Good. We move on to the next type of vector, which is called collinear vectors. These vectors are lie along the same line. The two vectors lying along the same line, then they are called it as collinear vectors. ಒಂದೇ ಲೈನ್ ಮೇಲೆ ಇರ್ತಕ್ಕಂಥ ವೆಕ್ಟರ್ಸ್ ನಾವು ಕೊಲಿನಿಯರ್ ವೆಕ್ಟರ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಒಂದೇ ಲೈನ್ ಮೇಲೆ ಇರಬೇಕು. They have to be in the same line. Okay. The different category is the coplanar vectors. The name itself indicates the coplanar. Two vectors in a same plane. Two vectors lying in a same plane, they are called as coplanar vectors. ಒಂದೇ ಲೈನ್ ಮೇಲಿದ್ರೆ ಕೊಲಿನಿಯರ್ ಅಂತ ಕರಿತೀವಿ, ಒಂದೇ ಪ್ಲೇನ್ ಮೇಲಿದ್ರೆ ಕೋಪ್ಲೇನಾರ್ ಅಂತ ಕರಿತೀವಿ. Okay, coplanar vectors are the vectors lying on the same plane. Okay, so these are the different kinds of vectors, and we come to know the definitions of these different kinds of vector. In fact, this is a very basic topic. You might have learned these basic things in the second PUC itself, maybe in the first PUC. Yeah. Now, So after learning the different types of vector, we need to know the addition of two vectors, how the two vectors has to be added. It is not a simple algebra, it's a vector algebra. You need to understand how these two vectors has to be added. Okay. There is a rule here, there is a law here to add a vectors. That law we call it as parallelogram law of vector addition. Okay. There's a parallelogram law here. So let's know what is this parallelogram law is. Okay, if two vectors acting at a point, be careful, the two vectors has to be acting at a single point, are represented in both magnitude and direction by adjacent sides of the parallelogram. ಎರಡು ವೆಕ್ಟರ್ಗಳು ಒಂದೇ ಪಾಯಿಂಟಿನಲ್ಲಿ ಆಕ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದು ಮತ್ತೆ ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಮತ್ತೆ ಡೈರೆಕ್ಷನ್ಸ್ ನ ಎರಡು ಅಕ್ಕಪಕ್ಕದ ಸೈಡ್ ನ ಪ್ಯಾರಲೋಗ್ರಾಮ್ ಆಗಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡೋದಕ್ಕೆ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದಾದ್ರೆ ಓಕೆ then the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram. ಆ ಎರಡು ವೆಕ್ಟರ್ನ ರಿಸಲ್ಟೆಂಟ್ ಏನಿದೆ ಅದು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಮತ್ತೆ ಡೈರೆಕ್ಷನ್ ಎರಡನ್ನೂ ಕೂಡ ಯಾವ್ದು ಕೊಡ್ತಾ ಇದೆ ಅಂದ್ರೆ ಡಯಾಗನಲ್ ಆಫ್ ದ ಪ್ಯಾರಲೋಗ್ರಾಮ್. Okay, right, with the pictorial we can understand it's better. Okay, see one vector, this is P, which is OA. Another vector is OB, I am calling it as Q. Suppose if I have to add these two vectors, okay, suppose if I can represent these two vectors by the two adjacent side of the parallelogram, okay, then the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram. That means diagonal of the parallelogram will gives you the resultant vector, which is P plus Q. P plus Q is given by this diagonal. Whenever you have to add two vectors, if you can represent this by two sides of the parallelogram, then this diagonal will gives you the resultant of these two vectors. Okay, right. So this is the one way we can add the two vectors. This is also a very simple thing, and you have learned these kind of addition of vectors in the second PUC. Of course, there is a triangular law of vector addition also, and these are the very simple things you have learned in the first PUC. Yeah, subtraction. This is a very interesting thing. Addition you can do it with the parallelogram law, but subtraction you need to have some tricks here. Okay, suppose if A and B are the two vectors, I need to subtract the B from A minus B. I want to do A minus B. Okay, so if I want to do that, it's simply an adding A and the vector minus B. Okay, so instead of A minus B, what I'm doing is I am adding A and minus B vector. Okay, so how can you do that? So suppose I know A and I know B. What is minus B is? Minus B is invert the direction of B. Don't change the magnitude. Magnitude will remain same. Just invert the direction of B. Look at the diagram. This is the vector A and this is the vector B. So if you want minus B, just invert the vector. Okay, don't change the magnitude. This length of the vector will remain same. Okay, but the only thing is I am inverting the direction. Now I got minus B. Now I have this minus B and this A. Now I am going to add this A to this minus B. How will you add this? Addition of a vector. We have a parallelogram law of vector addition. Luckily I can represent these two A and minus B by two sides of the parallelogram. Then this A minus B, the resultant, will be the diagonal of this parallelogram. Look at this diagonal. This diagonal will gives you A minus B. Whenever you want to subtract a vector from another vector, just invert this vector and add these two by the known law, that is the parallelogram law of vector addition. It's a very simple trick of subtracting the two vectors. Resolution of vectors. Yeah, Resolution means, the word meaning itself indicates it's a splitting of vectors. It's a splitting of two or more vectors. Okay. Now, how can you do that? How can we split a vector into two or more? We know addition of a vectors, we know subtraction of a vectors. Now, the thing is, how can we split a given vector into two or more vectors? Okay. So, vectors into which a given vector is splitted, is resolved, is called the component of a given vector. Suppose this P is a vector. Look at this vector P, which is OC. OC is a vector, and I am splitting this P vector into OB and OA. Okay, so if I split these two vectors, these OA and OB are called component of the vectors. ನಾನು ಪಿ ವೆಕ್ಟರ್ನ ಎರಡು ವೆಕ್ಟರ್ ಆಗಿ ಸ್ಪ್ಲಿಟ್ ಅಪ್ ಮಾಡಿದ್ದೀನಿ. ಪಿ ವೆಕ್ಟರ್ನ ಎರಡು ವೆಕ್ಟರ್ ಆಗಿ ಸ್ಪ್ಲಿಟ್ ಅಪ್ ಮಾಡಿದ್ದೀನಿ. ನಾನು ಸ್ಪ್ಲಿಟ್ ಅಪ್ ಮಾಡಿದಂತ ವೆಕ್ಟರ್ಸ್ನ ಏನಂತ ಕರೀತಾ ಇದ್ದೀನಿ? ಐ ಆಮ್ ಕಾಲಿಂಗ್ ಇಟ್ ಆಸ್ ಕಾಂಪೋನೆಂಟ್ಸ್ ಆಫ್ ಎ ಗಿವನ್ ವೆಕ್ಟರ್ ಪಿ. Okay, right. So we need to understand some more things here. So this P vector, I have resolved this into OA and OB. What is OA? What is the length of OA? Length of a OA can also be found out. Suppose this is the angle theta. Okay. So if that is the angle theta, so this OA would be P cos theta. How will I got this P cos theta? Look at this triangle OCA. In this triangle OCA, if I do cos theta will be OA. That means the adjacent side OA divided by the hypotenuse OC. That is P. Okay. So cos theta is OA divided by P. And if I do cross multiplication, OA will give you P cos theta. Okay, just by looking at the triangle, by applying cos theta, I got OA as P cos theta. Similarly, you take this triangle, you will get OB as P sin theta. Okay, now this one vector P is resolved into two vectors. One is P cos theta along x axis, another one is P sin theta along y axis. Okay, ಇನ್ನೊಂದು ಸಣ್ಣ ಮೆಥಡ್ ಏನಿದೆ, ಎಲ್ಲಿ ತೀಟಾ ಇದೆಯೋ ಆ ಸೈಡ್ ನ ಪಿ ಕಾಸ್ ತೀಟಾ ಅಂತ ತಗೊಳ್ಳಿ. ಸೊ ಎಲ್ಲಿ ತೀಟಾ ಇಲ್ವೋ ಅದನ್ನ ಪಿ ಸೈನ್ ತೀಟಾ ಅಂತ ತಗೊಳ್ಳಿ. ದಟ್ಸ್ ಅ ಸಿಂಪಲ್ ಲಾಜಿಕ್. ಓಕೆ, ಸೊ wherever there is theta, you take that side as p cos theta. Wherever there is no theta, you take that side as p sin theta. Okay, that is how easily you can split any given vector into two or more components. This is what the resolution of two vectors. So here comes the scalar product, and this scalar product or dot product, you have not studied this in the first PUC. This is a new thing for you in the for BSc. Right, we will understand this product is. Now we understand the addition of vectors, we understood the subtraction of vector, we understood how a vector is splitted into two or more vectors. Now the thing is product. How will you multiply a vector? How will you get a product of two vectors? Now there is a kind of multiplication which I am doing. Okay, the resultant of multiplication is a scalar. Okay, so I am doing a kind of multiplication for two vectors, but the resultant is scalar. That's a magic. ಎರಡು ವೆಕ್ಟರ್ನ ಯಾವುದೋ ಒಂದು ರೀತಿಯಲ್ಲಿ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ ಸ್ಕೇಲಾರ್ ಬರ್ತಾ ಇದೆ. Okay, how I am doing this? The scalar product of two vectors A and B can be defined as the scalar quantity which is equal to the product of magnitude of two vectors and the cos of the angle between them. Okay, so A is one vector, B is another vector, and theta is the angle between the two vectors A and B. Now if I want a dot product, if I want a scalar product, that scalar product is equal to modulus of A and modulus of B and cos of the angle between the two vectors. It is A B cos theta. A AB cos theta is a scalar quantity. It is not a vector. If you do a scalar product of two vectors, you will get a scalar and the magnitude of that scalar is AB cos theta. So A dot B ಮಾಡಿದ್ರೆ ನಮಗೆ ಸ್ಕೇಲಾರ್ ಕ್ವಾಂಟಿಟಿ ಬರುತ್ತೆ. ಸೊ ಎಷ್ಟು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇರುತ್ತೆ ಅದರದ್ದು ಅಂದ್ರೆ AB cos theta ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇರುತ್ತೆ. Okay, so this is all about the scalar product or the dot product of two vectors. Okay, we'll move on to the next thing. This is vector product. We call it as cross product also. Okay, here I am doing a kind of multiplication where the resultant is vector here. ಇಲ್ಲಿ ನಾನು ಒಂಥರದ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ನನ್ಗೆ ಏನ್ ಬರ್ತಾ ಇದೆ, ನನಗೆ ವೆಕ್ಟರೇ ಬರ್ತಾ ಇದೆ. I am doing a multiplication of two vectors and I am getting a vector. This kind of multiplication is a vector product. Okay, so vector product of two vectors A and B is again a vector quantity which is equal to the product of magnitude of two vectors and the sine of the angle between them. Be careful, here it is sine of the angle between them, whereas in the case of scalar product it was the cos of the angle between them. Okay, so if I want A cross B, earlier I used to write A dot B for scalar product. Now I am writing A cross B. This into mark has to be read as cross. A vector cross B vector. So A cross B will be equal to modulus of A, means magnitude of A, and the magnitude of B and the sine of the angle between them. Okay, with the diagram you can know the things. This vector is A, okay, and this vector is B, and theta is the angle between these two vectors. So I want a cross product. So if you want a cross product of two vectors, then it will be the modulus of A and the modulus of B and sine of the angle between them. But this is a vector quantity. You need to represent this with a vector, with a direction here. So n cap will gives you the direction of A cross B. You need to compulsorily write the n cap here because n cap will represent the direction. Okay, so this AB sin theta will gives you the magnitude of A cross B and n cap will gives you the direction of A cross B. N cap is a unit vector which is in the direction of A cross B. Okay, what is the direction of A cross B? I know the direction of A, I know the direction of B. What will be the direction of A cross B? A cross B ಅನ್ನೋದು ವೆಕ್ಟರ್ ಪ್ರಾಡಕ್ಟ್ ಆಗಿರುತ್ತಲ್ಲ, ಅದು ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ? We have a rule here, we have a law here to find the direction of A cross B, and that is right hand screw rule. There are many laws, of course. The right hand screw rule will gives you the direction of A cross B. A cross B is a vector quantity. Magnitude is AB sin theta and direction is given by the right hand screw rule. Suppose if you screw it, if you screw a screw from A to B, there is an A vector, there is a B vector. If you screw it from A to B, the direction in which the tip of the screw moves will gives you the direction of A cross B. Now ಒಂದು ಸ್ಕ್ರೂ ಅನ್ನ A ಇಂದ B ಡೈರೆಕ್ಷನ್ ಗೆ ರೊಟೇಟ್ ಮಾಡಿದ್ರೆ ಸ್ಕ್ರೂನ ಟಿಪ್ ಏನಿದೆ ಆ ಟಿಪ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗುತ್ತೆ ಆ ಡೈರೆಕ್ಷನ್ A cross B direction ಆಗಿರುತ್ತೆ. Okay, of course the tip of the screw will move perpendicular to both A cross B, both A and B, sorry, both A and B. The tip of the screw will move perpendicular to the plane containing A and B. Suppose this is a plane containing A and B, the tip of the screw will be perpendicular to both A and B, means the plane containing A and B. Screw will be perpendicular to the plane containing A and B. There is another rule here to find out the direction of A cross B, and that is right hand thumb rule. This is an interesting rule. It may look left hand for you, but this is a right hand of me. Um, Means we have two vectors. Okay. Now place your stretched right palm. This is a stretched right palm in the direction, stretched right palm perpendicular to the plane of A and B in such a way that the fingers are along the vectors A. Okay, so your fingers should be along the vectors of A. Okay, when the fingers are closed, they go towards B, means B is in this direction. When you close the fingers, this goes into the direction of B. And look at the thumb will gives you the direction of A cross B. Here is A and this is B. Thumb will gives you the direction of A cross B. Exactly the same as the screw rule, but it's a different kind of analysis. Okay, with the thumb we can with the right hand thumb we can analyze the direction of A cross B. This is A and this is B, and thumb will gives you the direction of A cross B. Okay, so this is right hand thumb rule. We have two rules. One is the screw rule, right hand screw rule, and the right hand thumb rule to find the direction of the vector product, that is A cross B. So the new thing which you have learned today is the scalar product as well as the vector products. The remaining things are the just glance of the thing which you already learned in the first PUC. Okay. Yeah, these are some of the reference book, which is very good book. Holiday Resnick, The Principle of Physics. Of course, H.C. Verma, Concept of Physics, uh, Volume 1. And we have in our own university, people have written one of the good book called Understanding Physics by Mangalore. You can also refer these kind of books. Thank you very much. Thank you.